Hey everybody, welcome back to Unit 4. We're going to take a closer look at isosceles and equilateral triangles. So this is a single piece of paper. It should be a shorter video. So if we recall, we learned that there's four types of triangles by sides. There's acute, obtuse, right, equiangular, and then there's three triangles by sides. Equilateral, isosceles, and scalene. We also learned that the interior sum of a triangle is 180 degrees, and we also learned the exterior angle theorem, which says if you have a side of a triangle that is extended, that angle that's on the outside of the triangle is equal to the two non-adjacent angles added together. So we're going to learn a little bit more today about isosceles triangles and a couple of their unique relationships. Sorry, I was trying to think of the word. And we're going to talk about a little bit more of equilateral. So the parts of an isosceles triangle, we have two congruent legs. So in here we have AB and BC as the two congruent legs that are denoted by these two tick marks. The angle where the lines intersect is called the vertex angle. So B would be the vertex angle. The opposite of the vertex angle is called the base. So this side AC is the base. It's like the side that's alone, that doesn't have any relationship to anything. And then we have the two base angles that are down here, which are A and C. Okay? So the isosceles triangle theorem says if the two sides of a triangle are congruent, then the angles that are opposite those sides are also congruent. So what does that mean? So it's if side AB is congruent to side BC, then the angles that are across from them are also the same. So that means that angle 2 would be congruent to angle 3. Right? So now this is just the theorem up here reversed, and it just says that if angle 2 and angle 3 are congruent, then the sides that are across from them, so then AB is congruent to BC. All right, it's just the opposite. So if the sides are congruent, then the angles are congruent, and if the angles are congruent, then the sides are congruent. All right, so what does that mean? Let's try some. So we have this triangle here. It's an isosceles by the two denoted ticks. So the base angles would be the same, so that means angle J would be 68. To find angle K, we would just have to do 180 minus 68 to get 44. All right, so this one's a little bit different. We want to find those base angles. Those two would be the same. So the first thing that we'd have to do is we have to do 180 minus 106. And if you take 180 minus 106, I think you get 74. Then we have to divide 74 by 2 because these two angles here would be equal, and you get 37 degrees for C and E. All right, number 3, you have X and Z is 77, so to find the measure of angle Y, we would just do 180 minus 77 to get 26. And since these angles are the same, the sides would be equal, therefore YZ is 12. Okay. So obviously we're going to add some algebra into here. So using the isosceles angle theorem, these two sides are the same, so these two angles would be the same. So we would set them equal to each other to solve for x. So we have 5x plus 9 is equal to 8x minus 30. Simplify, we get 3x is equal to 39. X is equal to 13. Same thing over here, sides are equal, so therefore these base angles are equal. So 4x plus 7 is equal to 9x minus 33. We have 5x is equal to 40, x is equal to 8. Down here we have the opposite, so we're told that these angles are equal, therefore these sides are equal. So we have 15x plus 7 is equal to 23x minus 17. Simplify and solve, we get 8x is equal to 24, x is equal to 3. And last one, on the front side, angles are the same, so therefore the sides are also the same. So 9x minus 73 is equal to 3x plus 23. We get 6x is equal to 96. X is equal to 16. Okay, back side here. We're told angle RST is a triangle and you have two sides that are the same. So what I always do is I always draw it out. It's always better to have a picture to look at and then identify what is there. So I have a triangle. Here's RST, RT, and ST are the same. So if we look at this, it's an isosceles triangle and we're given angles, so we need to find what angles would be equal. Well, that would be angle R and angle S. So we need to set angle R and angle S equal to each other. So 9x plus 2 is equal to 13x minus 18. We get 4x is equal to 20, x is equal to 5, and then all we do is plug this in. So for R, 9 times 5 plus 20 is 47. 13 times 5 minus 18 is also 47 because they're base angles. And 17 times 5 plus 1 is 86. All right, the next one here, draw your triangle that's given, DEF, and we're told that angle D and angle E are the same. So we are given all of these sides, so we have to determine what sides are equal. Well, if the two base angles are the same, it would be the two sides that are across from them. So we have DF and EF. So those two sides would be equal. So 4x minus 8 is equal to 7x minus 35. We get 3x is equal to 27 and x is equal to 9. Plug it in, we get 9 plus 4 is 13, and 4 times 9 minus 8 is 28, and obviously this one's also the same because it's equal. All right, 10, again, when in doubt, draw it out. So we have WXY. We have WX is congruent to WY. So we're given angles. So angles X and Y would be the same. So we need X and Y. So 5X minus 12 is equal to 7X minus 48. We get 2X is equal to 36. X is equal to 18. And then plug it in. 18 plus 6 is 24. 5 times 18 minus 12 is 78. And that other angle is also the same because there are two congruent base angles. Okay, the last section that we'll complete in this video is talking about equilateral triangles. An equilateral triangle, if we remember, all sides are equal, and it is the case that if it is equilateral, then it is equiangular. So if your angles are all equal to each other, then all the sides are equal to each other. So we're going to say then AB is equal to BC, which is equal to CA. And likewise, if all the sides are equal, then all the angles are equal. So the measure of angle A is equal to the measure of angle B, which is equal to the measure of angle C. So equilaterals are super easy. If you think the interior sum of a triangle is 180, so if we take 180 and divide it by 3, that means every single angle is going to be 60 degrees. So let's look at number 11. A is 60, B is 60, and C therefore is 60 degrees because they are all the same as the other ones. Angular also means equilateral. So if this is 9, the other two sides are also 9. We're told for number 12 that this is 24, therefore all of the sides are 24, but that's not what this problem is asking. So if it is equilateral, then all the angles are the same. So they are all 60 degrees. And the last one, we need to solve for x and y here. So let's solve for x. If you see that this is an angle, it is an equilateral triangle, which means it's also equiangular, which means every angle is equal to 60 degrees. So when you solve this, you get 7x is equal to 63, and you get x is equal to 9. Now we need to solve for y. This is very much like the other video when you're solving for a side but you're given all 3. These sides are all congruent. However, we only need to pick 2 of them. And I always told you pick the easiest 2 to set equal. It'll make your life easier. So I'm going to do 9y plus 1 is equal to 11y minus 23. We get 2y is equal to 24 and y is equal to 12. And that's it. Hope you enjoy the video. Bye.